All right, so let me try to share my screen. And can I get a thumbs up, or could you please let me know if you are able to see my screen?
Yes, we are able to see the screen.
Awesome, thank you. Um, Good morning, everyone, once again, and afternoon and evening to some of you. Today, I'm here to talk about one of the engineering discipline that has been emerging and kind of defining how we are basically deploying AI agents in production. And I strongly believe that this specific discipline is going to be one of the key discipline of this decade. Um, Now, before I jump into the details around it, which is called harness engineering, let me quickly introduce myself. My name is Sourav Saha. I work as an assistant vice president and in the capacity of a senior software engineer in the US Bank, where primarily I am involved with designing and architecting enterprise scale data pipeline, data platform, and cloud native distributed system, predominantly in the fintech sector. So now, what is harness engineering? Well, let me ask you this: like, could you please raise your hand and let me know like whether you have used ChatGPT? Nice. And how many of you have seen it hallucinate? Exactly. So basically the questions today is not that whether AI can work in the production environment. The question has become now whether it can work reliably and at scale in the real production scenario with real production consequences. That's very important to keep in mind, the consequences, right? Now that is where the harness engineering comes into picture. So it's basically the practice of designing and defining the constrained environments and the infrastructure that make the AI agents reliable at scale. Now, in this specific case, there are many like many analogy that I could draw, but the main part here is like if you think of a horse and reins, like the if horse is the LLM, the large language model, then the harness is the reins that basically controls it and gets you to the destination, right? So that's what the harness engineering is. Now, moving ahead, now why we are talking about harness engineering now, and this specific term again has been coined by OpenAI. It has come into the market. This term is like premature, I would say, but it's kind of getting very good traction. And people in the enterprise level, we are basically focusing on this one to make it more robust. Now, why it is mattering now? Now, if you go back in time around 3 to 4 years, 4 years, then probably what we were doing, we were basically back then trying to compare ChatGPT versus Grok versus other LLM models that we have, right? DeepSeek, that is one of the favorite one that I had or I experienced. So basically, back then we are comparing which model is better. Today, what we are doing is like we are not anymore comparing because all of these advanced models are pretty close in terms of performing. So they are well adopted in the industry. So what is the question? The question here is like what is the matter? The matter and the question here is what is that competitive advantage that you want to take. So in this case, in harness engineering is the key to that. Here the point is the competitive advantage here is like what model we use is becoming less relevant day by day rather than how we wrap it around with other technologies to make it reliable and being adopted by the industry with trust is becoming the main aspect of it. So that's why it matters now. It doesn't matter now to build an agent. Most of us, everybody builds an agent today within couple of seconds, couple of hours or minutes, if not days, right? Because it has become so much of easily accessible and available. But what matters is now when you build the specific agent, how do you make sure the specific agent is going to win the trust of your customer and it can perform at scale in production. So with that thought, let's move ahead and let's talk about what are the three. major pillars for harness engineering. Now, the specific concept, it was being referenced from one of the British software engineer who goes by Martin Fowler. He is kind of an advocate about enterprise architecture and all, and the term was kind of defined by him. You may want to look him up in martinfowler.com. He has his own blog. Now, for harness engineering, the three major pillar that we look at is one is context engineering, and then it is architectural constraints, and then it is entropy management. So what is context engineering? Now let's assume like we have an AI. Let's take any example. Let's assume like we have an AI financial advisor, right, who advises us on investing our money. So if we have an AI financial advisor, in terms of context engineering, what it means, like what that agent can or cannot see. For example, in this example, do you want your agent to see the PIN and PCI data in the banking industry, that is payment card industry? That's the question to think about and wonder about and see, like, should we give that access or not to that agent? When it comes to architectural constraint, it's all about like what that specific agent can or cannot do. For example, in this case, would you want to allow your agent to move money from one account to another without your notice or without even taking your permission automatically? Well, as of today, I would say no. That's my personal opinion. But again, those are the things we need to think through. And entropy management is like the performance of the agent over a period of time. It manages the degradation quality of it, so quality of the degradation process basically. So now in the same very example, the question would be how, or the point that we need to keep an eye on, how the specific agent is behaving after 100 conversations. Is your financial advisor performing better after 100 interactions, 1,000 interactions, or it is starting to drift? So all these three pillar basically defines how the reliability of that specific agent is going to work in the production environment. And this goes for any product, right? The trust is not about like any specific sector. For example, do you trust your agent to work in a banking system, or say in a hospital, or think about, or in an aeroplane, right? So we are using agent, but we are little far from the fact that to get that confidence in the agent to be able to fearlessly use in a situation like inside an aeroplane, or in a hospital in full-fledged manner, right? So that's what the harness engineer comes into picture, and where this three pillar serves the purpose. Well, now when I'm talking about harness engineering, I just wanted to very careful and try draw the line between the difference of harness engineering and prompt engineering. Here I am highlighting about five problems that prompt engineering cannot solve. But the point here is, I just want to make sure we understand the prompt engineering is completely different than harness engineering. For example, a prompt engineering is something that we all are habituated with, and probably all of us many times have heard in our workplace or outside of work, right? Hey, write a better prompt to get a better result, right? So prompt engineering cannot solve the traceability and observability and all. So I'll talk about it briefly, maybe with an example down the line. But I just wanted to have this prompt engineering term out there on the table for you to keep an eye on this as well, so that we do not confuse this one with harness engineering. And again, these slides talk about harness engineering versus prompt engineering in different dimensions, what the differences is. I'm not going to bore you by reading this through from the slide, but rather I try to jump into my next slide, where I try to explain what the differences is from the real data. So this has been taken from, again, OpenAI Anthropic, and where when basically prompt engineering and is kind of there, and the harness engineering was getting introduced, and it was getting tested out. So this is a real data, real numbers, where in same team, within the org, like team A, who was focusing on the prompt engineering, and there was another called team B, who was focusing on the harness engineering. And there they were trying to improve the same model, the performance of the same model, where in the prompt engineering, when the folks worked for 3 weeks to tune the context, to tune the prompts, to fine tune the quality of the prompt, and that gave them around 3% of completion rate advantage of it. by 3% of completion rate increase, meaning like the completion rate for that model was at around 85%, and but they gained around 3%, and it became to 88% because of whatever the changes they did in this 3 weeks, keeping that prompt engineering as their focus point, right? Now, the completion rate is nothing but how many tasks that agent can complete. Say if it is completing 85 tasks out of 100 provided to successfully out of 100 in a stipulated time frame, then the completion rate is 85. But keeping that same methodology, keeping that same model, right? When it was being tuned by harness engineering, in 2 days, the team was able to gain around 13% of the completion rates, which is a drastic improvement. It's not incremental, right? It's categorical. That's what I would like to highlight. It's like it's something like say for example you have a Maruti Suzuki today, and then tomorrow you have a BMW, and then after some time you have a Cadillac, right? So it's kind of natural progression. So that's incremental. But when it comes to categorical advantage or categorical benefit, it's something like today you own a Cadillac, but tomorrow you own a private jet. So it's completely different output at all. It's not comparable in that aspect. So harness engineering should not be confused with prompt engineering is what the point is I'm trying to make. I hope it helps. Now in terms of harness engineering, so what the harness engineers build? So basically, as I said, the harness engineers are basically building everything around the model, but not the model. Harness engineers doesn't build the LLM model. They do not train the model, but what they do is they basically builds all the guardrails around it and all of the checks and balances so that it keeps that model in its own track where you want it to be, and so that it can take you to your destination or whatever the objective you have. So that's what the hardest engineers build. Okay. Um, so here are some numbers in terms of market demand right now that we are observing based on at least in the banking sector what I'm seeing, and I'm pretty sure in different other sector as well, more or less in harness engineering perspective, around 3.2 job openings are there if the candidate is qualified. And again, I just wanted to highlight that harness engineering is something that most of the folks who are working in the application programming, application designing, the hardcore programming concept and paradigms that we are all aware of, that a software engineer does, right? If we are into that part, it is for those folks to kind of transition from there to harness engineering is not that complicated or difficult. It is the same thing that we have been doing, writing good, clean code. But right now we are going to code it up around the AI, the LLM core model, so that the core model can aid you into your system. So that's what the harness engineering is. And where the industry is heading in terms of harness engineering. So as I have highlighted here, prompt engineering is becoming a baseline skill, not a specialty, right? But again, I would like to highlight one more point here in this slide is, see, harness engineering is not replacing prompt engineering. It's difference is categorical, right? We just talked about it. So basically, if the prompt quality, if that's the floor for the room that you are building, then the harness engineering is the ceiling. So basically, you need both of your room for your room, both of your floor as ceilings to build your room, right? So just be sure that when we talk about harness engineering, it is completely is getting built on top of it. It's not replacing or competing in any way prompt engineering. Well, with that, I would like to leave you with one final thought. If today's session gives you at least one idea or one perspective or even one action that helps you to move towards your career goal, then my time this morning with you has been well spent. And also, I want to say, and like, if if somebody asks you about AI or LLM down the line, I hope you'd remember that LLM is just the horse, whereas the harness is the thing that get you to your destination. So with that note, I'd like to say thank you to all and hand it back to you. So Right now, I'm open to take any questions if anybody has any.
Hi, Saurav. One question. Uh, is it right to say that the harness engineering is the advanced prompt engineering? Like if prompt engineering is base level, then harness engineering is advanced level. Is it right to say?
Well, in some aspect, and yes, and some aspect, no. There is no straight answer for this one. Whereas the
Hmm.
prompt engineering is very base level, as you said. I would agree to
Hmm.
that. This is why you are starting. We all started with that. You need to have your prompts in such a way so that your LLM can take it and feed it into the processing and move forward. But harness engineering is actually not in entirety the prompt engineering, because in the prompt engineering you're focusing on the quality of the prompt, right? For example, in your prompt, you can ask LLM, hey, do not use more than 10,000 token, or hey, do not go and do this and this task. I want you only to think or source only from this specific sources in order to perform your job. So that is something you are telling the prompt, telling your LLM to do via prompt engineering, right? But there is no guarantee your LLM is going to listen to you, right? You can advise, you can try to push it via your prompt, but there is no way you can put that guardrails or put that limitations on that LLM to say like it will exactly do what you just said. It may hallucinate, it may go beyond that. There is no hard limit to it. But when it comes to the harness engineering, it is basically explicitly coding around your model and then putting the guardrails in place. It is explicitly putting the securities and limitations. Like for example, you wouldn't want your LLM to break the security system that you have, right? All the token based security or whatever we have based on our requirement. So it is basically the system engineering and programming that we do that comes under harness engineering. That's where it differentiates itself from prompt engineering, if that makes sense. Did I
Yeah,
answer your question?
sort of just follow-up question on this. This is Astimal's. Then how do you differentiate context engineering? You may differ to not answer it, you know, but
So
follow-up
context
question, what
engineering,
you, yeah.
yes. So context engineering is one of the pillar, if you remember, we talked about in one of the slide. So in that case, what you do in the context, you are trying to define, that is one subject area of it. It's not all of it, right? So in the context area, you will be defining the context, how the context is getting refreshed, how you are dynamically injecting the context, right? So that specific part is on the harness engineering. So it's a broader umbrella, it's a part of it, if that makes sense. So these are kind of interlinked with each other. There is not like hard segregations with each other, but harness engineering, that particular sector and that particular subject area itself is taking so much of traction. And we as the like designer, architect, developer, whatever you say, we play different role at different situations. In that sense, we are basically focusing more on like how our agents are going to be trustworthy, right? The trust is the big factor. We can start with context engineering and prompt engineering. It gives up some good answers and numbered in generative AI. That gives us that ooh factor. Business gets very happy with that to start with, the initial impression, right? The right after that, when business starts asking more and more questions to the agent, a slightest deviation in the answers or wrong answers take away the trust from the business folks, and that is why we don't get the approval to use the agents in production, right? um, so to get our products to that level where we can completely trust it and make sure that this particular product that we have in our production, whatever it is not going to hallucinate, is not going to give us a wrong direction or wrong answer. To bring it to that percent level is where harness engineering helps. Good questions. Thank you. Yep. Anything else or anybody has that we can brainstorm?